Yes, hello and a warm welcome to the Digital Twin in Battery Cell Production Q&A. And nice to have you all here in this remote version of the Q&A. We will start with a quick round of introduction. So who is talking to you? Who is it that will be presenting to you the content, and who is it that you will have the discussion about the Digital Twin in Battery Cell Production tonight? So my name is Krauß. I've been working at Fraunhofer for 7 and something years now, and I'm working at the Fraunhofer FFB here in Münster, so a Fraunhofer institute that focuses on battery cell production. I'm working here as the head of department for digitalization and battery cell production, and yeah, looking forward to deep dive into the topic of digital twins today with you. And with this, I'm handing over to my colleague.
Hello, everybody. Also from my side, I'm Arno Schmetz. I'm also part of the digitalization department here at Fraunhofer FFB. I myself also have been working with Fraunhofer for more than 6 years, I think now, and also have been at Fraunhofer IPT in Aachen before, and now I'm also part of the digitalization department at Fraunhofer FFB, dealing especially with digital twins. What brings us to today's view and today's webinar in a live Q&A session in here, just to have a deep dive on digital twins. I'm happy to get to your questions later on and have a nice discussion in there.
All right. Now some rules for this event, or the concept that we figured out for tonight. So you should have a chat in some form in front of you. Some of you already used the time to send us some questions in advance, which we will answer over the time of this Q&A session. And those of you that come up with questions over the course of this event, you will have the opportunity to simply type in your questions in the chat, and then we will interrupt our presentation and our discussion in between to directly answer your questions. And if you have some follow-up questions, feel free to post them as well. And we will try to answer everything as good as we can. And with that, we will jump over to the agenda. So we will start with a quick introduction into the Fraunhofer Society, especially the Fraunhofer FFB, so a Fraunhofer Institute for Battery Cell Production. And afterwards, we have some main topics that we will go through. So we will start with a general definition. What are digital twins? What has been developed over the past years or past decades in the topics of digital twin? And then for those of you that read the white paper that we brought out, so we have some printouts here. But over in the chat, you will receive a link for the download of the white paper. What we did in this white paper is that we clustered the different types of digital twin into the machine, the product, and the building twin. There are several others, but these are the 3 digital twins that we will focus on tonight. So we'll have this as element 3, 4, and 5 for today. And then if we have some time remaining, we can make a spotlight on some of the use cases at our place here in Münster, battery cell production. So this is the rough agenda, and Arno and I, we will take turns in presenting some of these spotlights, and then in between we'll answer the questions. And with that, I'm handing over to Arno for the introduction of the FFB.
Yes, thank you very much, Jonathan. Yeah, so Fraunhofer FFB, for the first glance, you get a context and insight of what we're doing in here and who we are in here. Of course, so Fraunhofer, I think, is a name. So we are doing applied research, biggest institution for that in Europe. So this is our main course, what we're doing in here. But also inside Fraunhofer, we are special because we are having the build-up of real factories in here and do research in the real factories in there. So very special inside Fraunhofer, but especially something we do for you and especially for the industry to get knowledge in there, and having an open battery cell factory for your research and development projects and purposes in there. So this is what we're doing in there. You see, Münster is located in Germany, more to the western side of Germany, of course. And then you see in the rendering on the right, this is our, let's call it the largest part of our equipment and our buildings we build up. So this is our fab in the end, which is having the size of a real gigafactory. You see, it's somewhat about 7 gigawatt hours per year as a electrode production. So this is a real gigafactory at a large scale, as it's coming up for many of the factories right now, announcing right now on a major weekly basis for whole Europe. And we're doing this with a team of roughly 150 people in Münster in here to do the all research on that. But of course, this is what we are aiming for, especially the innovations for the efficient and sustainable battery cell production. But this is the end version, the end building we have in there with the high scaling in there. But this is also a way, and there's also one step in between. And this leads us to our prefab, which is especially where we are located right now, some kilometers from here in distance. So it's the prefab in there. This is the building we are building up right now, or which is the actual building is built up. And now we are getting into service more and more in the next upcoming months. And this is something more like a typical factory on European scale, what we're building up right now. So we're talking about something like 200 megawatt hours per annum. We're doing a production capacity in there. And also besides the several thousand square meters of the factory floor space for the whole production line of our power cells in there, we're also having some additional open spaces and innovation labs in there for your testing, scaling, and also development processes in there. Talking about cell formats, of course, we do power cells, but as you can see in front of us standing in there, we're also doing prismatic cells and also cylindric cells in our assembly lines. So we're doing all of the major form factors in there, especially you see a high energy version of our power cell in there. So this is what we are doing right now, and we are producing at Fraunhofer FFB. So that's about the basic of who we are and where we are. Of course, our expertise, I mentioned we're doing production in there. Of course, we also look into the other aspects of what the whole production line and production cycle is talking about. So we're also looking into how the actual engineering of the battery and the designs are in their place. But of course, main focusing on the battery production, including the full scale digitalization in there. We come to it in a second, and also going into the battery use and the recycling and second use aspects in there. So how can we design and reuse something we have produced in there, and how is the whole data pipeline and data lifecycle connecting all of them? So based on that, of course, I mentioned there are research partners and we're doing applied research. So to give you a glimpse, what is this talking about? If you think of your technology readiness level, so how your technology is evolving over time and in maturity, you see, starting from a lower TRL ends, this is the typical area where you find research institutions and universities, more coming from a theory aspect, and then going from a lower TRL in there. And then we use the Fraunhofer FFB as a scaling partner in there, going from the mid TRL levels to the high level of TRL, enabling all the industry partners to use it in a proven environment, also at scale, and not only in, for example, small speeds for the machines, but the real large scale and high speed machines for mass production in there. So this is our special area we are working in. And you see some of our key partners on the left side. Of course, there are even more, some research clusters, research partners, and more. And of course, for you as possible partners, you can be placed on the left side or the right side, depending on the project we can do together. This is about how we are doing this together. And of course, what we are doing together. You see, these are the 3 steps we're doing in here. So from a lab scale to a mid-size factory, the prefab in the center, on the right side, our largest fab in there. This is what we are doing in there. And of course, what we are doing also in here is we're doing the development of an all-digital workspace. So our current lab, the all-digital prefab, so the mid-sized factory in there, and also the all-digital fab. So everything we do in here for the production, we do also in completely all-digital way. So we are building up multiple full digital factories in here to show to you how it's done and how to transfer to you. Of course, we do that. We use those, and we derive from that some building blocks we can also bring to you on your side, or what you can bring to us for evaluation and testing inside our infrastructure. So this is what we're doing in there, especially with the forms of transfer arising from that, based on the on-site solutions for your for the partners. Where you come, for example, with the transfer blocks, also having the adaptions or joint developments, especially in there, coming up to the larger parts of standardization and also knowledge transfer. But of course, especially also validation partnerships from the small scale to the large scale gigafactory scale is possible at our infrastructure with you as a partner. So this is our main idea of how our battery cell digitalization is enabling the production of all industry partners, and also how we offer our services and want to join together forces. So this is what we're doing, and especially by having our own full connect digitalized factories, we show that we can do that and want to bring in and gain the knowledge and provide the knowledge about what mistakes are often to be done in there and how to avoid them, and especially how to do your digitization right with our help. So far for a first glance of what we are doing in here at Fraunhofer FFB. But of course, this brings us for today's topic, which is digital twins. And digital twins are key aspect for us also. And so these key aspects and this key technology is very interesting. And therefore, I hand over to Jonathan back, going to the definition of the digital twins we will see today.
But maybe one other topic, central topic, in addition to digital twins, are questions and answers. So do you have any questions regarding Fraunhofer as a whole, or especially the Fraunhofer FFB in Münster? So yeah, the special Fraunhofer Institute that focuses on battery cell production and the research in battery cell production. Feel free to ask your questions in the chat now. If there are no questions coming, then we will jump over to the main topic, which are digital twins. So let's start with some motivation. What you can see here are two curves. You can see they're plotted over the time. Those of you who like small riddles can maybe try to guess what these figures try to depict. I will add a clue. These are some numbers from 0 to 1.2K and to 200. And yeah, those of you who have been in contact with digitalization and with in contact with battery cells might have already have a clue. So on the left, you can see the global demand for lithium-ion battery cells over the time, so the expected global demand. On the right, you can see the volume of data that is created worldwide over the time and how it's expected to grow. So we can see these two trends, two things that are moving upwards over the time. And one central question that can be derived from this is how we can make use of this data and make it available to increase sustainable in a growing battery cell production. Because on the one hand, we have this global demand for battery cells, but what of course goes in hand with this is the fact that we need sustainable approaches to produce our battery cells. And so this is one motivation. How can we combine these two curves here, or these two figures? And one way how this can be done, can be traced back to the late 60s, early 70s. Back then, the NASA developed the concept of the first twin. So back then, some of you might remember it. Some of you might have read it in Wikipedia or had it in history lessons. Back then, Houston had a problem, or the guys in space had a problem. And back then, what the NASA did is that they created a physical twin of the actual spaceship, and they had this physical twin at the Johnson Space Center at the ground at the US and Texas. And what they did by them is that they gathered all the information they had from the problem in space, and they recreated everything and at the physical twin at the ground station. And based on this, they were able to draw the best conclusion to help the guys in space based on this physical twin they had at the ground station. So this was the first time that a twin was used. Back then it was a physical twin, not a digital twin. So what changed over the time is not that this concept of a physical twin, which was used back then by NASA, that this is combined with the possibilities of Industry 4.0. And this leads to the current topic of digital twins in production. Digital twins in production, their origin back some years already. I will come to this later, what has been done there already, but still the motivation is to combine the physical twins with Industry 4.0. And the thing that we here in Münster, together with our partners in Aachen, in Stuttgart, etc., the thing that we are doing is that we take this concept of the digital twin in production and we combine it especially for the battery cell production. This brings with it some special challenges, some things that are not a problem in other domains. And I will dig into that later and explain what the main challenges at the battery cell production are. But still, this is the motivation, bringing the digital twin to battery cell production. So what we hope for today is that we can answer these three already existing questions. So what is a digital twin for the battery cell production? How can we improve our production with a digital twin? And how is it possible to realize it, to implement it, to deploy it? These are three key questions we want to answer, in addition to maybe the other questions that you have in mind. So how can we define the digital twin, and how can we bring it into battery cell production? What we did already, say 2 years ago, together with some colleagues in Aachen, was that we analyzed every existing definition of digital twins out there, dozens of existing definitions, and what we were able to draw from it is that there are so many perspectives on twins, and one of the main things we figured out is that there's no existing definition, or there was no existing definition for twins for battery cell production. This was the one aspect, and the other aspect is that the motivation why you bring in a twin or why you develop this, largely or strongly depends on the respective use case. So depending on what you want to achieve with the twin looks quite differently. So one thing we did roughly 1 year ago, which led to a corresponding publication, was a definition that bases around existing definitions, but it focuses on the battery cell production. And here at the top you can see some text or a written definition. A digital twin is a digital representation of a specific object, which might seem quite trivial, but still there's already some potential of discussion there, because what is a specific object? Does a specific object have to be physical? And this is already something where you can draw a lot of discussion from the literature, from scientific discussion, but also from discussion from practical users. And from the broad perspective, a twin is only possible if you have a physical object available that is represented by the twin. So the twin comprises the property, states, and the behavior of the object via data, models, and information. So we have this property, states, and behavior in the real world, and we have data, models, and information in the cyberspace or in the digital world. And the twin has the task to comprise all of this. One other thing that the twin does is that it includes data, models, and simulation from the entire life cycle that can be useful in each of the life cycle phases. And this already brings us to the problem of what is the use case you want the twin to be developed for. And depending on your use case, you have other data, other models, other simulation that you put into your twin because it's necessary for your use case. So a twin might be developed for a predictive maintenance case. You want to be able to predict how long your element in the machine will last. And if you set up a twin for this, then you have simulations that focuses on your tools, on your element, on the toolware, etc. But if you set up a twin that you want to use to predict the quality of your product, then you might have total different data, information, models, and simulation in your twin. And this is covered by this definition. And what I already said in the beginning of the presentation is that you have different kinds of physical objects that are represented by the digital twin. And we had some long discussions over the last 2-3 years with all of the battery cell manufacturers, all of the asset producers, etc. We had all of the discussions of what is represented by the digital twin. And we had long discussions with people from the building sector. For them, it was quite clear that a digital twin is only meaningful if the whole building is represented. And then you have people from the machine vendor perspective that said, I don't really care about the building. I just want to have a twin for my machine. And then there were people from the production design, from chemistry, etc., that said, I don't care about the building either, but I want some information about my product. How does it evolve over the time? Especially from a sustainability perspective, you want to have all of the data available for your product over the course of the time. And so we have here 3 depictions of how the twin for each of these 3 physical objects can look like. So these are 3 examples from the battery cell perspective. At the top, you can see a snippet of one form of a twin of the building. Then in the middle, you can see that a twin for product might not be a visualization, but simply a well-structured database over which you can collect all of the data for your product over the time. And the interface for a machine twin might be a dashboard, which gives you a real-time access to your data of the machine. So these can be these different forms, these different kinds of objects, but also show how different a digital twin can look like. And as I already said, the twin largely depends on the use case. And one central element of the use case is what is it that you improve with your digital twin? Because the digital twin itself does not make a lot of sense to create the digital twin, and then it's not possible to write any euro sign, CO2 emission reduction, scrap reduction behind it. So when you set up the twin, you have in mind the use case, and you might also have in mind a service that is enabled with the digital twin, or sometimes you might even put the service that is enabled within the digital twin. And so what we did here is that we wrote down a first overview of possible use cases for each of these twins. And I will just point out one or two examples, because we'll show some more examples, or we can show some more examples later. If we, for example, take a look at the product twin, if you have all of the data available of your product, so your battery cell, that about which material was used to produce it, which machines were used to produce it, what was the amount of energy that was consumed to produce this battery cell, and you have the product twin for this battery cell available, it's possible for you to conduct a life cycle assessment for this specific battery cell and have this very transparent information available for each of your cells, which brings a lot of advantages. So on the one hand, you have this certainty about where was it produced, what were the conditions under which it was produced, but also you have the possibility to, for example, if you have some problems with your battery cells in the field, you can use your digital twin of your battery cell to then, only start measurements activities for those products that were for which it's necessary to start these activities. So this is one example how a twin for a battery cell can help, but a twin for a battery cell can also be useful within your battery cell production, but I will come to it later. And if we take a look at the twin of a machine or an asset, of course, one of the most discussed topic is predictive maintenance. So for example, if you have a coating process in battery cell production, you might want to be able to predict how long your nozzle will last and when you have to change it or when you have to clean it. And then this is a use case where a twin of the machine makes a lot of sense. So this is just a small glimpse on what is possible with twins for building, for product, and for machine. And of course, if you want to take a deeper look, you can check out the paper. But also, we will now in the following conduct deep dives into building, product, and machine. And this brings us again to our main topic, questions, where I see one question that was sent to us beforehand, which we can try to cover.
Yeah, exactly. So also for your information on the outside, there were some questions also brought in beforehand. So we also want to take those into account today. So sometimes you see, of course, all of the time you're free to add your questions, put your question to the chat. We will come to them also, but also, of course, also the people that sent us in beforehand some questions, we also use those questions right now. So maybe the first question, Jonathan, it's about, you mentioned different kind of twins we had in there. And there was a question about how the actual topic of the materials is handled. So whether should there be maybe a digital twin for materials, or where is the material of the battery cells in the end to be hosted?
Yes, it's a question that we discussed a lot with people from the chemistry domain, because they have this view for material, but also people from the supply chain domain who said handling the material is quite critical. And basically most of the aspects that cover the material, they flow into the product twin. So this battery cell that we have here, and we can see the twin for this battery cell, then the twin also covers information about the material that was used to produce it, or the material that was that the battery cell is made of.
Nice. So of course, if in any case you have additional questions to that topic or to a question or to an answer that comes up, please feel free to get it in the chat. So there was also, similar to this question regarding the materials, there was a similar question I saw, and this was about the logistics actually. So also logistics, of course, a huge part of the production, and there was no logistics twin. But of course, you also said there's something about this has to be an asset. So how to be, where in this whole trinity of digital twins in there? So where in there is the logistics be placed?
Yeah, it's a topic that we also discussed a lot with other research institutes, but also with other industry partners. Actually, if you take a look at these three kinds of twin, there are a lot of other topics that it's difficult to put them there. So for example, what you do with a handling robot is a handling robot part of a machine, like you set up a machine twin for it. And same goes with the logistics equipment, so in AGV. These are all things that are not directly covered by these three elements here. So this is something that we are working on right now, that we set up a fourth, fifth, and sixth kind of digital twin that then covers, for example, AGVs and, for example, some handling robots, which we do not completely see as covered with the machine twin. And yeah, this is a first approach how everything can be covered, but not every physical object in the system, in the production system, is covered. One quite interesting object that was also discussed, I think 1.5 years ago, was how about plants? Like, do you have a digital plant twin? And also the topic was there, how about the humans in the factory? Do we have digital twins for the humans as well? And yeah, these are topics that we shifted a bit to the later stages and started with the three most relevant twins.
Yeah, of course. Who does not want to have a digital twin of himself being placed or being useful somewhere around? But of course, they are also a research partner on the outside, more up aside from battery cell production, that all go also into the depths of some kinds like that for the plants and for the people in there, for example. But very interesting topic, and maybe also, as you were mentioning about the concepts in there and what is being put aside and maybe more to the future or later stages, as you mentioned. There was also a question, someone looked at the website, I think, and said, okay, so you're mostly going into the lithium ion batteries right now. Lithium ion batteries. So is this concept we see in there, is it also transferable to, for example, new trends like the all-solid state batteries or natrium ion batteries or something like that?
Yeah. Definitely the concept is transferable. The good thing when we come from the digitalization domain is that you try to set up things as transferable as possible. And especially in the product twin, if we take a look at the ontologies, the data structures, the data models that we have there, then it's quite easy to simply adjust it and add the new chemistry that you used into the structure. So it's something that definitely is covered by the digital product twin. One thing that we see as sometimes more challenging is what do we do with our digital twins of the battery cells in later stages? So if we put them into packs, modules into the car, and then you have this system that is being created by different digital twins. And yeah, this is a topic where still a lot of different concepts are being tried out. But yeah, regarding the all solid state battery and other cell chemistries, the concept is transferable.
That's great to hear, because of course what will we see for batteries in next years? So we will come in that together and join forces for the research on that. So this has been some questions we had in beforehand, and one question that just came up at the moment in here. But so nice people out there, do you have any more questions? Please feel free to get into the chat in there. But also, of course, if in the afterwards of this live Q&A session afterwards you have questions, we will see in the chat in some moments also again some information about contact for us. So please feel free all of the time just to drop an email by, or just get your phone call and get in contact with us. We are happy to talk about digital twins and the possibilities for you at your site, for example. Thank you very much, Jonathan.
Yeah, you're welcome, Arno. And with this, I'm handing over to the first deep dive, and the first deep dive goes into digital twins of machines.
Nice. Thank you very much. So as Jonathan mentioned before, of course, there are, for example, many machine factories right now ongoing in the market, especially from Europe. There are some major players, but also, of course, outside from Europe. And of course, if you talk with them, they often come directly to the point, say, okay, so I have a machine, so what? And my machine is very complex. So what is for most benefit for me? Of course, some kind of a digital twin of my machine, and what is the benefit arising from that? So what we're doing with that then is we deep dive again. So this was our trinity of digital twins we saw them before, and this is now we're going in the first deep dive of digital machine twin. So,
all right, maybe I'm going to quickly interrupt you because we have one question in the chat. Maybe we can answer it before we go to deep dive. The question is, how do the different twins interact with each other?
Oh, that's a really good question. I just go back some slides in here. Yeah, as you see, for example, so we have our digital twins at different stages for different aspects, different assets in here. But of course, having a twin for itself and having a service attached to this twin itself maybe generates some kind of a benefit or a service applied to something. But of course, if we now have thinking of the battery cell production line, we have multiple machines in there. They're placed inside a building, and also they're producing many cells in there. So in the end, we have a multitude of different twins in there, and of course we want them to interact with each other, because then by the use case you can decide which kind of information and data has to be interchanged with each other. So from the use case side, so if you're getting, for example, into the topic of an LCA, for example, or want to achieve, okay, what is for my whole production line improvement, I have to deal with, okay, so maybe in my first electrode production steps, something like the mixing step, there's a parameter that has an impact on the later stages, like the coating process. We have to link those twins together and make them communicate with each other, while also at the same time they're influencing or having an impact on the actual quality of my cell in the end. So this is definitely inputting some information into the product twin in the end, and also being influenced on the parameters by the actual building environment, so by the building twin in there. So this is how we see they have to work with each other together. And how we achieve that is, of course, we have different systems in there, and also we are dealing with open standards in there for the interconnection and for the interfacing in there. So we are always aiming for how can we bring in the interfaces between those digital twins, being usable in there for direct methods with open standards in there. So we want to, we do not want to have multiple that data silos somewhere lying around, or something like only proprietary interfaces that no one can pay for or can use in there. So we're always aiming for open standardized APIs in there.
And maybe this connects to another question that was sent to us in advance. So the question that was sent to us in advance was, for machines, OPC UA gets more and more attention. Is there an OPC UA digital twin standard? And maybe we can broaden it a bit and go away from the OPC UA, which is quite machine-oriented. But in general, what do you think about what are standards that we can expect when it comes to the interaction of digital twins?
Yeah, that's a very broad topic, a very nice topic in there, because there's so many things ongoing right now in there. So especially, of course, the one question that a bit more about OPC UA, which is coming more from the machine view in there. So we also have to, with all of twins, we have to look into what is the common languages and the common things and standards that are ongoing right now in there. So especially for the machines, for example, there's OPC UA ongoing, and there is ongoing work we know of, which is dealing with standardization for battery cell production in there, also going towards competitive specifications and more. So there is ongoing work. But also on the other hand, if we see, for example, the buildings or also material in there are also ongoing works, which are especially dealing, for example, with ontology topics. So this is there's a technology where you can describe interlinkage of information and describe knowledge with that. And by those interlinks, for example, you can then model what is going on, and also link between what is going on. So if I have this material, how is this material linked with its properties to another parameter of my machine, and then going this straight line of information and influences all the line away. So this is something, there's just two technologies to name for, which is ongoing right now. But of course, there are much more ongoing right now. And we're also looking into all of those, and also looking into, okay, how can they benefit for our use cases in there? And for our case, we are very, very open with all the technologies in there. So we want to try new technologies and evaluate which of them are useful and or not useful for the use cases.
Cool. And because it's another question that matches it. yeah, regarding OPC UA, there have been some involvement over the time, but from your perspective, when it comes to standards for digital twins interacting with each other, from your perspective, what do you think is the are the most the entities that most likely will create the standards? Is it like public entities? Will it be more entities from the industry? What's your perspective on it, or will it be a combination?
Yeah, I think in the end it's a combination, but more like an industry lead somewhere in there, because of you can have the best standard from a technical point of view. If no one uses it in the industry, your standard is likely to be dead. So this is the way it's going in there, and of course you see some actual ongoing work and also standardization work, and especially consortia building up, which is especially, for example, the IDTA, so the International Digital Twin Association, as one big stakeholder in there, which are also coming with an open technology front in there. So, for example, they are talking about the asset administration shell as one key technology they use, which is dealing with the standardized interfacing of information and whole structure to be placed, especially between the lifecycle phases of my digital twin. But of course, there are also other topics or other open source projects that are also dealing with the standardization more from a foundation and from the other kind of service where they're coming from, more from the computer science view, for example, like the Eclipse projects, like Eclipse Ditto or something like that. So these are ongoing works in there. Personally, I'm sure there will be some new developments, and especially also for the existing developments and standardization progresses, they will deal with how they can be combined and work together. So in this case, for example, you have maybe for the one digital twin that someone has implemented, there will be more like an asset administration shell focus on the technology, while another one has a Ditto, and the next one has a completely different in there. So they need to have the interconnection of those and operability in there.
Yeah. All right. I hope that we answered the question. In case we did not answer the question, please feel free to specify it or ask a second question, and we will answer it in between. And maybe we can jump back to the Twin deep dive.
Yes, definitely. Perfect. So perfect timing for the questions, because I was here for just getting the context again. And so now we are deep diving from the whole trinity of digital twins back to the digital twin for the machines. And in there, what we see, and this is a depiction you will see multiple times today from the concept in here, you see a layer model in here. So you see on the lowest layer, we see the machine itself. So take it, for example, our extrusion machine for the mixing process. So, and in there, now coming from the actual physical layer where the machine is placed, we go now back a layer higher, where we have a database on our data management level. We will see, of course, you have our machine environment, but also machine properties are placed in there. So more like static information, but also dynamic information like events, the interference, but also, of course, our own parameters and the actual data we take from the machine, from the ongoing process. Using all of those information and data in there, of course, before we just use them for analysis or for providing a service, we have to ensure it's interoperable and it's high quality of our actual data information plane. So by that, we have a data processing plane in there where we have a pre-processing. So everyone, especially data scientists, for example, know pre-processing is a harsh work, and that's not the nicest work, but it's needed because if you have bad data to be put into your data model, then will be bad quality of your actual result in the end. So this is the reason we have it in the central part in here, especially as the interfaces. We have been talking by the question before that we need interfaces to have the interoperability of everything in there, and of course also data mapping, because if we, for example, have something like standards for describing something, we need to map our actual data information towards those standards to make them interchangeable. Also in case, for example, I change my service on the top layer and I still want to have not my whole data pipeline to be reinvented, and then still want to use the same data pipeline. Using all those data pre-processing, we now come to the actual digital twin core level, which is then, of course, we have the data information and the models in there. And this is the key we bring up in there. Of course, we have the data and information we mentioned before, which is the key we bring up from our production in there, and our insights to be placed in there, but also the models itself to be placed in there. So for example, having a statistical model or the link to a simulation model, and to know how all those models are working together, how they are linked together, and what they are addressing inside my space for my actual physical object, my physical twin in there. And having all of those core, the requirements from the lower levels and the core components of my digital twin, the digital twin core level in here, I can now go up and provide services. So until here, it's everything about enabling and providing the enablement for the users and for the use case creators. And then the use case creators can then go, okay, I need a visualization, or I need some kind of, for example, my condition monitoring, which is a very typical task people want to do, because I do want to know what is going on in my machine, in my production, and is my condition, is it working or is it hurt in there? So of course I need this in here, but of course we can also go further. They have a kind of a prediction, for example, for predictive maintenance, which is a hot topic for, I think, more than 10 years now, how to perform this predictive maintenance. If we have a digital twin, we can enable this predictive maintenance in a good, high quality fashion. And of course, I can also go into my machine back, taking the whole turn again. So if I have my models and I know what's going on, I can then go into, okay, how can I optimize what I'm doing? So maybe for my extrusion machine, what are the actual parameters I can change for the good, and then bring them back to the to my shop floor level and into my machine in there. So this is the whole idea behind this graphic in here. You see, also very a question we get often from outside when we are talking with people about that. They often ask us about, okay, so are you planning to replace some existing systems like an IoT platform or an MES? And the definitely clear answer there is no. We do not want to take over or replace any of the other systems that are existing for good reason in the production. But we want to bring on a new enabler, enabling more services at a low footprint for great value and added in there. So this was very layered in abstract way in here. Maybe get an example of what I'm talking about. So if you think about, again, you see on the bottom right, this is, for example, our extrusion machine. And here you see a 3D rendering, a CAD model from our actual production machine here in Münster. And now, of course, we have our machine components, we model in there, and they have, for example, a screw configuration. So it's extrusion machine with a screw configuration in there. And of course, we have process parameter we can configure in there. For example, the drive speed. But also we have a property, which is then coming from the actual process that's ongoing, which is the specific, for example, the specific mechanical energy we bring into the actual mixing in there. And you can see by all those arrows in here, what actually happens is we bring all of the data upwards to the digital twin level in there. But while we do that, we also see that the properties of my process are influencing my actual process parameters, while the parameters are also influencing the configuration I need for my machine, while my machine components and the configuration of them impacting my quality for my actual process properties in there. So you see everything is interconnected with each other, and having by the digital twin and the interlinking and the modeling in there, we can go into the depth of that and also link them with each other and go to, okay, so based on what we saw in there by the data and also maybe additional several small cases, we can have, for example, a quality prediction of my slow process production in there. This is a typical example of what we're doing with digital twin in here. So you see our digital twin area on the top is our enablement for having a service like the quality prediction. So based on that, you see this has been our machine twin and what we're doing with that to achieve benefit in there. Of course, this can also be done for so many more different machines we have in there, but now not only more machines, but hopefully also more questions. So please feel free to get some questions.
And the good thing is, I just wanted to jump to the list of questions from beforehand, but just in time, there was a new question. So the question is, there's a trend for mini environments and housings.
How?
Do they make the building twin obsolete? So it's a question focusing on the building twin, but maybe we can already try to answer it.
Mm-hmm. Yeah. Very good question. So mini environments or micro environments, depending on manufacturer, a very hot topic right now, and especially in the battery cell production, we need, for example, clean room and dry rooms. So having, instead of a whole real expensive dry room, can we just give a housing for the actual one machine and have it smaller scale, and by that also reduce our costs in there, but by that also reducing the footprint we have in there. This is an ongoing also production technology topic, but of course for digital twin it also has an impact, because on the one hand we have our building twin by definition where we have the full building and the environments. But of course, if we now having the talk about mini environments, this does not make the building obsolete for two reasons. The one reason is still there's a building, so you do not place your mini environments in a harsh environment outside of the street, for example, hopefully. So based on that, of course, we need still the building twin in there with all its services. Maybe can reduce the complexity from our dry rooms in there, also our building twin for the models, but still we have something ongoing in there. And on the other hand, the building twin itself also deals with environmental information and how environmental information influences different aspects of the digital twins that are inside the actual building. And this is something we can directly copy and take over for all the mini environments in here. Because mini environment, we can deal with it as like a small building twin, which is placed inside the great building twin, but in the building twin in there, and inside there, there's all a machine twin. So by this kind of caging inside or stacking inside, this is completely analog to what is going on a hardware level. So it's completely fine with the physical assets. And then we can also having this environmental information and our structures for that to be reused per mini environment again from the building twin proposal before.
Yeah. One thing I would like to add to this is that a huge discussion we are still having is about how about clean and dry rooms? Are they a machine, an asset, or are they part of the building? And in which of these twins is it being simulated? The smaller you make your clean dry room, more towards micro environment, the more emotional the discussion becomes. So it's still it's still a good question, because the smaller the clean and dry room, the closer to the asset, and the more you are maybe motivated to see your clean and dry room, your very small clean and dry room, as a machine or an asset, and therefore you want to set up a digital twin for the machine and asset. But for us, until now, we consider the clean and dry room as part of the building, and therefore we set up a digital twin for the building, and one part of the building is a clean and dry room. And there's another question. So the question is, how can we as an OEM get started if we wish to build up a digital twin system? Maybe you can start to answer, and maybe I will add some information.
Yeah, that's a very complex question. My personal thought on that is, of course, you should start with a kind of a use case, because if you want just go to, okay, I want to have everything at all at once now, you're having a high complexity, and it's hard to get the people on board because they not see directly the benefit of having a huge change of something or a huge introduction of a new system or a system framework and everything at once in there. So this is also something I think we had this discussion, for example, for the whole digitalization in before some years ago. There were some studies they are pointing out if you're just having a full change with everything, or a wide broadened change to be forced from the top level, and not taking the people working with it into account and bringing them on board, most of those problems are likely to fail. So this is something, by that I would be focusing on having a good idea of what we want to do, but also then going into the use case that we can keep everybody on board and bring everybody on board. So why we're doing that, what is the benefit behind that, and why we're getting started with each other, and also what are the different views on that. So for example, for a CEO, this will be another view on digital twin as for a technician or a data scientist in there. So also taking those different views into account, what are your thoughts, and also your interconnection, interfacing, and interaction with those digital twins, for what reason? Yeah, this would be my take on that, but I think you've also an additional interesting topic.
Yeah, I totally agree with what you said. Some things I would like to add. The one thing is that before you start working any form of the digital twin, it makes sense to have a clear understanding within your company, and especially with the stakeholders, what is the goal? Why do you want to go towards the direction of digital twin? Is it more like marketing related? Do you want to have the image of yourself toward the outside, that you're digitalized, etc.? Then this might be a different motivation compared to we do actually have some problems. We see that we can solve them with digital twins, and this is, like, from my point of view, the first step to have the clarity. And then the second step from my point of view is expectation management. So take your time to understand what is it that digital twins right now from different vendors do cover, what is possible to conduct with them, and take a look at their showcases. And depending on this, you can make a first comparison about what do you want to achieve with the digital twin and what is available on the market, or what can be developed within 1 or 2 months, in regards to possible solutions and possible vendors. So these would be, from my point of view, 2 of the first steps what we conducted over the last 1-2 years, because of course we are involved in the development of the digital twin still. We see companies that do then the full support, etc., as the ones that roll out a digital twin over the 5 or 10 years, and these are companies that we collaborate with. So over the last years, we did a lot of discussions, talks with these different vendors of digital twins, so platform providers, etc., and made a screening. What are they capable of doing, and what is it that they're not capable of doing? So depending on what is your goal, what do you want to achieve with the digital twin, then making the assessment of what is possible within a short time frame, because maybe it's sometimes good to be visionary, but in a lot of cases it's important to have available results, good results within a short time frame. So these would be 2 other steps I would see as quite relevant in the beginning. Expectation management, what do you want to achieve, and then which is available within 1, 2, or 3 months, a check-up, what of these goals are available and what are not that easy available. And I think there were some more questions. Who should provide or develop a digital twin of a machine? The equipment manufacturer or the process responsible? I think with process responsible in the battery cell domain, we could say equipment manufacturer would be a company that engineers and produces, for example, a coating machine, and the process responsible would be the battery cell manufacturer. So Arno, what's your point of view? Who should provide it and why?
Yeah, that's a good question. We had multiple discussions, especially with machine vendors in there. Yes, so I would think in this case, you provide a machine. So, for example, there's someone having a machine, and you're the provider for the machine. You are the expert for this machine right now. So it's, in my opinion, it's your task to think about, okay, so what is my digital infrastructure I can provide and want to provide, how far for my actual machine I'm providing in there. So do I only want to provide a full physical machine working on its own, or do I want also provide digital infrastructure behind that, especially digital twin in there? And so by that, being the experts for your own machine, you as a machine vendor, highly qualified and the natural first person to bring in the digital twin for the machine itself, and also having the development of a digital twin, which is then also be linked perfectly and aligned with what your machine is doing, and also can then directly by that also manage the expectation from your customer what your digital twin is linked towards your own machine, without getting or providing too much knowledge about the internal of your own machine. So this would be the hot take to say, okay, for the things that are directly attached to your machine and which can be completely provided by you as a vendor, you should be, or you could be a very high staker in that, and also having a high glance for your competition to say, okay, I have my machine, I have a complete digital twin in companion with that being in there. Of course, if we're going more to use cases, then based on what with all the data information, what can I do with that? Of course, you have a machine vendor can bring in many of those aspects and many of your services in there on your own. But even more as your game go into more and more into the actual production of the cell manufacturer in there, then you have more and more also getting knowledge about how the whole production line is functioning in there, and also what is going on inside the business case, for example, for the cell manufacturer, and then more and more shifts towards the development of these services for digital twin towards the actual cell manufacturer or technology provider for this manufacturer. So in the end, you see, my old tech would be, in the best case, you get when I'm buying a machine, in best case, I get directly a full-fledged digital twin of my machine directly attached to it and can use this for the extension of services, then maybe with the vendor together or with technology partners in there.
Yep. And maybe what I want to add there is so over the last years that I did projects together with companies that try to roll out digital twins. I had projects where we supported machine vendors in setting up their digital twins, but also we supported companies, the producing companies, and accessing the data from the machines and setting up their digital twins for the production system. So both is possible, and we can see good practices, best practices in both scenarios. And one thing that we are doing right now is that for each machine that we bring into our facility, we have, for most of the machines, we have bilateral projects with the machine vendors and developing a digital twin for each of this machine that is being brought into battery cell production. So there we are more on the perspective of we develop a digital twin together with a machine vendor, but on the same time, we as the Fraunhofer FFB for our production site, we also create a digital twin of the whole production system, so the aggregation of the different machines, and this is something that we conduct here. So you can see there also there's no answer like it's only this partner who creates a digital twin, but it depends on the level of abstraction in which you're in. And so this is both possible, and because the question only focuses on the two possibilities, equipment manufacturer and process responsible, over the last years, I had a lot of projects, strategy projects together with partners that were these third party that were not able to produce any machine. They were not running any production site, but they were trying to bring in an additional layer between the different machines and the producer. And this is a third option and a third possible vendor of digital twins for machines. And all three options I've seen in the past, and all three options I've seen as successful approaches. It was a lot of fun conducting these projects together with these partners because the perspectives and motivations are so different. So if you're one of these three kinds of partners, feel free to reach out, and we can have a deep dive discussion about it. And then we do have more questions. Is the material flow for powder also represented? If so, how was this realized? I think the material flow is here meant as the material flow within the coating machine, not the material flow in the whole production system. Do you want to start with the answer?
Yeah, I can start with that. Yes, so as John already mentioned, so we are splitting in there between what flow of material you're looking at. So for the whole logistics material, we're going more to building twin, but what is going on for the flow inside the actual machine itself, we're going to the modeling inside the machine and the twin for the machine itself in there. So this would be, for example, when we go for the coating example, this would be something we are looking into, for example, having, can think of having your pumps or your slot die or whatever you have in there to be modeled, and also this model and the knowledge attached in there. And by that, you model what is going on, and also the material flow internally of your machine, as far as you need that for your actual use case. So, for example, if your use case, which is completely on a very high level, and you don't need to have much information about the actual material flow inside your machine, you can be having maybe a smaller statistical model in there. If you want to have really an optimization for each and every parameter inside your coating machine itself, for all details in that, then you have way more detailed flow analysis and modeling in there. Maybe also having some simulations based on that directly linked into there.
Yep. One thing I would like to add, because we have right now a focus on the mixing, extrusion, coating, and drying processes. For these twins that we set up and for the simulations that we conducted within it. So whether it's the powder, or whether it's the flow of the material in the nozzle of the coating machine, or whether it's the drying process and all of the thermodynamical aspects you have to consider. In general, there are three approaches how this simulation for prediction can be realized. So you have white box, gray box, and black box models. So white box models mostly focus on physical behavior. These are simulations that you can set up before you actually run the process. So for example, using MATLAB, ANSYS, etc. Then you have the black box approaches where you mostly build on data you gathered over the time, and then you set up statistical models trying to predict what will happen. And then you have gray box models where you have a combination of both. And especially due to the fact that battery cell production is still a domain where you do not have a lot of data from the past available. In the beginning, we completely built upon white box simulations, so a lot of ANSYS going on, a lot of MATLAB simulating going on. This was where we started. And now over the last roughly 1 year, we started for the aforementioned processes, we started setting up gray box models. So we had this white box part, and then right now we are enriching it with a black box part. So on the one hand, the black box part, we have this last term of uncertainty, which you model with the statistical behavior. And on the other hand, we also use the black box part for optimizing the parameters within the white box model using reinforcement learning. So this is one of the main approaches how we are conducting the simulation right now in battery cell production, bringing together this two worlds. Also very interesting, and it's also impressive how much you can still discover, even though these companies are in the area for so long. All right, then we have the next question. How can digital twins be used to predict and prevent production errors and defects?
Yes. Again, I will link towards the two aspects of that. Of course, on the one hand, you can have on that position, you have a direct influence or direct knowledge about, okay, so this kind of a process will have an impact on my quality, for example, or my can cause a defect. For example, in some encoding, for example, if I say, okay, there's a slot type problem, so by that I have then the problem of my quality inspection there. We can use the digital twin in there because we saw this digital twin core in there. We have a guaranteed quality of our data information in there, and also know about, okay, so what is my insight, my knowledge about my process and my defects I know about, and can link them against the data. So by that we can see, okay, what is going on, and link those information together. And by that see, okay, so classify what has been going on, what is the most prominent cause of that, or based on the data we see, also say, okay, based on this kind of data in the past or by the model, we see this is likely to have a defect right now at this kind of a sheet or at this meter of my production line. So this is what we have on a very specific level of one digital twin for my production, for example, for the machine. But of course, if we're going then for the whole scale in there, we have the interconnection between digital twins in there. Of course, we can also then link additional information in there. So maybe I see in the later phase of my assembly line, there's a kind of a problem, but we can say, okay, so I have a problem with my different anode and cathode not being linked perfectly or not being aligned perfectly to each other because of a size difference. Maybe we can then link back to, okay, so there was about something my electrode production that has an influence on that. So where can I find the cause of that again? And other way around, having this next time some of this kind of data in there, maybe can I then adapt my condition monitoring at the first glance just to prevent it afterwards, or at least detect where are likely to be some defects in there in the later stages.
Yep. All right. I will not add further information because we do have some more questions. So next question. In the upcoming years, we have to train a lot of people with new skills in battery cell manufacturing. Could digital twins support us there? And if so, how?
Yeah. Definitely a huge challenge we are facing right now, because now everyone wants to produce some battery cells. Of course, we need experts for that, but we cannot harvest battery cell production engineers and experts like plants somewhere, so they need to be trained. And what a digital twin in there is also be capable of, we have the information, the insights especially. So for example, if you go to a production, you have different kind of people in there. So for example, if we're talking about your shop floor, let's start with your shop floor. You have maybe some kind of an basic technician at your shop floor, which is with the aim of, okay, I want to produce, and now there has been an error comes up. So the typical thing would be, okay, so you have your plant manager or some experts, and they're usually telling you, okay, so there was the problem. To solve this, you usually do this and this and this. So you're having some resources to be bound for that, and also you have to bring knowledge towards those people. Of course, if we're using a digital twin, we have the knowledge already in a digital form. So how can why not bring take this information, this knowledge, and provide them directly in the moment something happens. So think about something happens in your machine. So for example, in your coating machine, I'm using coating machine very often, I know, then maybe there is something, you see there's a defect, and while the defect is happening, you have a kind of a companion, for example, at your site, which says, hey, there's something happening on there. Maybe you can try this or that. This could be leading to a better quality. So the people are then getting, during their ramp up as a person inside the production, can having help and being faster for becoming an expert. But also, of course, if you're not being there at all, of course, the first glance of, okay, what is my production looking like? What are the key aspects in there? And what has to be looked into for me as a battery engineer or also maybe a data scientist? I can also have a first glance using my digital twin for a representation, a visualization, to look into, okay, what's the project looking like? To have a virtual a round trip to my production, and also looking, okay, so what is this exactly? What is happening here? And getting by that and support for gaining my knowledge in there from a higher perspective, but also an in-depth, detailed knowledge, because we all have all of those knowledge and information available in our digital world.
Yep. I just have to remember back then when we were still setting up the workspace, so our lab scale, that before we actually brought in the machines, that we made a full 3D model, so a 3D digital twin of the building and machines within it to identify, are there some collisions? How is it if I walk around it? And we did a full 3D model and used it to get a first insight into how the lab would look like, which was quite entertaining. And we figured out a lot of challenges while walking through it, which we were then able to avoid using this digital representation. I would add two other things that you said regarding the development of the skills. So on the one hand, if we look at other domains, so other producing domains, then we can see that after you have a first stable run-in process, at the latest then, a lot of cases earlier, the whole topic of digitalization, statistics, etc., this comes more and more relevant. So I see this as one of the following steps after now we get more stable processes. And on the other hand, when it comes to teaching people, educating people, communicating skills to them, then this is something that we here in Münster, we've been doing over the last 1.5 years. And one thing that we realized there was that on the one hand, you have this hands-on seminars where people go to the shop floor, they see how the production looking like, they get some crash courses into chemistry, they get some crash courses into how are the production processes running, how are the machines running, what are different machine vendors. So all of this, seminars, educations, and that there the topic of digitalization, how having all of the data available is something that completes this whole circle and brings them some additional motivation, seeing what is possible there. All right, we covered a lot of questions. Feel free to just add them. We will answer them in between. And still, we do have one question from that was sent to us earlier. All right, yes. Some points sound like other systems, MES, ERP. Where's the benefit of the Machin Twin?
Yeah. So as I mentioned beforehand, there we do not want to replace the other systems in there. So it's completely it's not to be replaced in there. But of course, if you're, for example, looking into the MES systems right now on the market or my ERP level, for example, often they are oriented for the production itself, but not for the details and depths of the modeling of what is going on in there. So for example, usually, or most MES systems I know are not capable or not wanting to have a deep in-depth simulation of what is going on inside my depth of my machine, for getting the knowledge and also providing me information. Okay, how can I rearrange or change my different parameters based on something that's happened in beforehand. So this is something we bring up with our enabler in here as a new possibility in there. But of course, still Digital Twin Core stays an enabler in there. So for example, if still your MES or other system you have available in there is capable of doing something cool, just keep it. We do not want to replace it. Keep your cool stuff. Of course, it's beneficial for you, then keep it. But of course, you still have an enabler for more cool stuff that can be then developed in a lower footprint for your development team.
Nice. Thank you very much for answering all of these questions. Right now, there are no questions in the chat, so we will go over to the next deep dive, talking about the digital product twin. And as Arno already said, you will see this visualization quite often. You might have also seen it quite often when you scroll through our white paper, because our general structure of the digital twin, so the general structure that we developed here at Münster, but together with a dozen other Fraunhofer institutes over Germany and different industry partners and different universities, this twin, the structure is, the layers are always the same. So you always have in the blue, you always have the physical world, and then you have these four cyber levels from database, data processing, digital twin, and services. And while the example that Arno brought, one case earlier was about the machine as the physical object that is being represented. Here we have the product, so the battery cell that is being represented. But it's not always a battery cell. So if you take a look at the bottom right, you can see the battery cell is one element that can be covered by the digital twin for the product. But you have all of this statuses of your product before that. So before it becomes a battery cell, simply there are electrode sheets. Before that, it's an electrode coil. Before that, you have electrode paste, and even before that, you have the raw material that you bring into your battery cell production. So this is one thing that, if we take a look at digital twins for products from other domain, makes the battery cell production specifically challenging. So here it's just a simple database, and then you have all of the feature, environments, process parameters, interferences, quality features, etc. available. But actually what happens in between the database and the physical world is very, very challenging. And it's a topic we've been working on now for 2-3 years. And yeah, it's a topic of traceability. You have to make sure that those litters from electrode paste in the beginning, those meters at the electrode coil, those single sheets, that all of them aggregate and interlink correctly to the final battery cell. And yeah, there the topic of traceability is highly interesting, and it's something where at the moment still there's no solution available that covers everything. So right now we are developing together with partners from the traceability sector, but also together with other battery cell manufacturers, we're developing solutions for a traceability system that covers this layer between the physical world and the database, and that we can interlink all of this. So we have the database that covers all of the elements that are specifically relevant for the product, so for the battery cell in the end, whether it's a prismatic cell that I showed earlier, whether it's a pouch cell that I showed earlier, whether it's a round cell, or whether it's a prismatic cell. All of this data is being kept in the digital product twin. Over the data processing layer, which is similar to the one that Arno explained at the digital machine twin, we go then into the digital twin layer, where you have the data information and models for the specific battery cell that you want to represent. And then you have these different kinds of services. I already said earlier that traceability is one huge topic. Another huge topic is the so-called battery pairs, which is on a way higher level, but still the battery pairs, it's an EU directive that demands all of the relevant, especially CO2 or sustainability relevant data, that you have all of this available for your battery from production over usage until reuse, recycling, re-X, that you have all of this available. And so this can be one service of the digital twin, to have this, let's say, print function that you use to then create your battery pairs of your battery pack. So these are different kinds of services, and I will go into a deep dive, which is about the connecting of process data and measured properties in a product twin. And the goal is to reduce scrap rate for early detections of the quality, reducing the cost and time by condition detection, and predicting the quality as a base for adaptive process control. So this is one way how we can use the digital product twin. If you have all of the relevant information available, then you can try to achieve these different goals by different applications. So for example, you can do database quality control at fixed decision steps. So in production, we do have the so-called quality gates, and only if a product has a certain quality, it can go to the next process steps. And one thing that we're working on right now is the let's say enhancement of quality gates, including prediction models into the quality gates, and they can only function if we have a working digital product twin in place that feeds its information to the quality gate, and based on the information, the quality gate can then say, okay, this product is okay, or this product maybe also most likely will fail in later stages. And this is something that we can see here as a rough depiction. So we do have a lot of information for each of our battery cells. So we might have some properties, for example, the slurry viscosity that was measured during the respective process phase. We might have some process parameters. So we had some parameters that we were able to collect during the process. So for example, the coating thickness. And then we might also have some information available attached to our twin of the battery cell, for example, of the homogeneity of the component distribution. And based on all of this data available, we can at later stages on the production, for example, before we go into the formation process, we can then use the data that is available for our digital for our battery cell. We can use all of this data that was collected until that point of time, compare it to past cells that went through our production line, and try to predict the, for example, formation process or the aging process, which leads to a huge reduction of used energy, huge reduction of scrap, and therefore a higher OEE over the whole time. So this is one example where the digital product twin is of advance, in addition to the example that I made earlier. And this brings me to our favorite slide, questions. Are there questions?
Yes, perfectly. Thank you for this moment. And before we go to the in-depth question for the actual product twin itself, there was upcoming another question, which is more like a general question, maybe I can forward to you. And this is a very nice question about what are actually offers for collaboration and how can we work with Fraunhofer FFB?
Yeah, great question. There are different ways of collaboration. So we as Fraunhofer, our business model is that roughly half of our money we receive with public funding, and half of our money it's projects that we conduct directly, bilateral way with industry partners. And while the first focuses on writing proposals, talking with the government, and receiving corresponding money, the other aspects, still making out 50% of the way how we work, is the way how we normally interact with industry partners. So we have different forms of interaction. The first point of contact always is we get a mutual understanding of what is it that Fraunhofer can do and what are the problems that the industry partner is facing. And after having this mutual understanding of it, there are different ways of interaction. There are ways of interaction where it's a more engineering development oriented project where, for example, right now, a machine vendor has some problems bringing the stability into its process. We have now some understanding about how the process is running, and we are collaborating with the industry partner, conduct the process parameter optimization and bringing stability into the asset in the machine. This is one way how collaboration works. Another way how collaboration works is with the topic of more strategy-oriented projects. So where a company might have some challenges about we don't know what is the next step and the following step and the then following step, having some uncertainty about it, and that we have this more strategic projects where we set up strategies for the partner. And then there are also other kinds of projects where we are working together with partners that have some challenges when it comes to bringing their personnel at the right education stage or the right knowledge that is necessary for the use case. And then this is another kind of project that we've conducted in the past, transferring our knowledge to the industry partners. So these are just some examples how we in the past conducted projects and supported partners.
Yeah, so you see, if you're interested or have some challenges, which is especially interesting for us, we can then join forces to challenge your problems and to get a better production for you or a better solution or overcome all challenges. So, but of course, there also been in-depth question about its product Twinn in there. And of course, let's go to them because there were some interesting questions, and especially you hinted at the CO2 footprint and life cycle at some moment of your talk. And so the question also came up about, okay, so now we have a product Twinn in there. How can we, or can it be used for having a kind of an to bring a label on it? Okay, so this is my CO2 footprint for my battery cell. This is my actual price I have internally for my product.
Yeah. So this is something right now. It's already possible to bring on your CO2 sticker, equivalence sticker on your battery, and say, okay, we assume that this battery cell consumed this amount of CO2 during production. But this is done right now on a very broad base. So in a lot of cases, you do not even really measure the electricity that was used to produce it. You don't really trace back the material to the base of it. You sometimes just know, okay, this product was produced in the year 2022, and this is the level of granularity that you had. But taking a look at our production, at the components that we use, sometimes we have recycled components, sometimes we do not have recycled components, and you have a huge variation when it comes to the CO2 footprint of your battery cells. And this is something where the digital product twin and the way that it's being set up right now can easily be used to set up the CO2 equivalent. And it's possible to bring in your sticker on your battery cell. And one element that we can see there as well is that the topic of battery pairs that I mentioned earlier, the battery pairs being something that is required from the EU. It also requires the CO2 footprint of a specific battery that is being used at, for example, a car. So at that point of time, it's another advantage of the battery cell twin, because you can simply use this data that you get from it, so CO2 emission for your battery cell, and just feed it forward into your battery pairs.
Yeah. Very great. There's also something that's also came up. So you mentioned already the battery passport, something like from the EU is coming, a regulation. So it's ongoing work for the details of the regulations. But of course, so from your understanding or from what you said, I understand this is something your digital twin can then feed into the battery passport, right?
Yes, correct. So on the other hand, of course, battery pairs can also be an input source for my digital twin of the battery cell. But the level of granularity in the digital twin of a battery cell is typically way higher than what the battery pairs requires. So in most of the cases, the data will flow from the battery pairs or from the digital twin of the battery cell into the battery pairs.
Perfect. And we are talking, there comes the next question. So this is also about, do you work on integrating physical models into digital product twins? For example, the model self-filling behavior.
Yes, it's something that we definitely are working on, and it's definitely something where we are conducted projects in the past, but we're also conducting projects right now. Especially when it comes to the physics-based simulation from material, from the filling processes, etc. These are projects where we collaborate together with other Fraunhofer institutes or other research institutes, or sometimes industry partners, but mostly research institutes, setting up these models. Because what we do have here in Münster is a knowledge about the process. We do have the machines available. We have expertise about the production processes, also about the products. But of course, there are other Fraunhofer institutes over Germany that have, for example, decades of experience when it comes to modeling specific material behavior. And this is the point of time where we, as the FFB, are an entry point into the Fraunhofer universe, where we then bring in the partners that have the biggest expertise when it comes to the specific simulation task. But especially when it comes to the filling behavior, it's something that we are working on right now. So whoever made the question, maybe leave your contact, and then we can go into a deep dive discussion, because it's something where I think we can discuss for another hour when it comes to the simulation, because it's definitely not an easy task.
Very nice. We just got information from a technical team in the background. So also credit for all of the technical team. Thank you very much for making all this possible right now. That the actual session we have right now in Teams is ending automatically in 3 minutes. So as you have been seeing, we are not quite through our agenda. So this is but for a good reason, because we had many questions, and that's the main task we are focusing in here. So yes, we will not make it to the whole discussion, all of the actual topics like building Twinn right now at this moment, but we promise at this point of time there will be a next session and also a follow-up on there, because there are many questions arising from your side, also many great questions coming up in here. So on that point of view, from our side, for this moment, we guarantee there will be next session. In case you have any question, please feel free to get in touch, get your questions right onto us, and we're happy to go into each of the discussions in depth with you all together. And until then, we can also only say thank you very much for attending and for all those magnitude of questions. We're very happy with that, and thank you very much for that. And thank you very much for our technical team.
Yes, thank you very much and have a great evening.